Hello everyone, in this video we'll be solving n queens problem, which is a very popular coding interview problem which is based on backtracking. So in this problem we are given a chessboard of dimensions n cross n, and we have to answer whether we can place queens such that they are placed on every level, on every row of this chessboard, and none of the queens attack each other. Like in this position, the queen at d8, that's not being attacked by any other queen, and none of the queens in this position are attacking any other queen. So this is a valid configuration, and this is a chessboard of a value for n is equals to 8, and we can have many such configurations. For example, if my n is 1, then there's only one configuration where I can place the queen here, and it is not attacking any other queen. So this is legit, and we have only one configuration. If my n is equals to 2, then I can place a queen here. This will be empty. And if I place a queen, I cannot place a queen here. And can I place a queen here? No, it will be conflicting because it will be attacked diagonally. So I cannot place a queen here. So what I do is I backtrack. I go to the previous level, which is the first level here. I say, okay, I'll remove the queen from here and I'll place the queen here. If I place the queen here, I go to the next level. I'll see whether I can place the queen here. No, I cannot. Can I place the queen here? No, I cannot. Now I again go backwards. I cannot place the queen here also, and this is it. I have explored all the possible locations for the first level, and I cannot place a queen anywhere. So I cannot place any queen here, so my answer would be 0 for this value. Similarly, for n is equals to 3, my answer would be 0. So let's explore how we go about this solving this problem for n is equals to 4. Let's place a queen here. This is empty, this is empty, this is empty. Now I cannot place a queen here, can't place a queen here because it is being attacked diagonally. I can place a queen here, right? So I place a queen here and I go to the next level. So this will be empty, go to the next level, cannot place, yeah, I cannot place here and I cannot place here, neither I can place here. So I can't place the queen anywhere in this level. So what I do is I go to the previous level and say place the queen somewhere else. So I place the queen at the last index, which is the last possible option we are yet to explore. So I place it here. I go to the next level. I cannot place a queen here because the queen from the first level that is attacking it. Second, can I place it here? Yes, I can. This is legit. I can place it here. It is not being attacked by any other queen. So I place it and I put dash dash and I go to the next level. Can I place a queen at the first index? No, I cannot. It is being attacked. Can't place a queen here. Can't place a queen here. Can I place a queen here? Well, I cannot because the queen of level 2 that is attacking. So I cannot place a queen here. So what I do is I go to the previous level. I say I can't place a queen here. I go here and I place a queen here. Whether I can place a queen here? No, I cannot. I go back. Can I place a queen here? No, I cannot. So I go to the previous level and I say like none of the configurations are valid. So I go here. I've seen all the possible configurations. So I go to the previous level now. I'll say place the queen somewhere else. So that somewhere else is this index. Now I come to the second level. Can I place a queen here? No, I cannot. Can I place a queen here? No, I cannot. Here, no. Here, yes, I can place a queen here. Now I go to the next level. Can I place a queen here? Yes, it is not being attacked by any other queen, so I am placing it here. I go to the next level. Place a queen here? No. Can I place a queen here? No. Can I place a queen here? Well, I can. Yeah. I can place a queen here and it is not being attacked by any other queen. So this seems to be legit, and I have placed 4 queens for n is equals to 4. So I go to the next level. I'll say okay, I basically placed the queen for the 4th level as well. So this is a valid configuration. So the counter, which will tell me how many valid configurations are there, that value will increase because this is a valid configuration. I'll set counter plus plus, and I need to backtrack because I need to explore all the valid configurations. This is just one of them. So what I'll do is I'll say yeah, I am able to place here, so I just increase my counter and I just go to the previous level. Yeah, and I say I can't place a queen here, and I go to the previous level, and like that I will backtrack. So that will give me, and that will exhaustively search me for all the possible valid configurations, and eventually the value of the counter would be the number of possible configurations. So this was one of the possible configurations for n is equals to 4. Similarly, there will be many more. So so the idea is, can I place a queen here? If I can, place it, go to the next level. If we are at the n plus 1th level, which means we have placed queen successfully for n levels, which means that the configuration is set, configuration thing is set, and I just need to increment the counter and go back and explore for more possible such configurations. So currently what I'm given as input is n, which is the number of possible, which is the number of rows and columns. It's a square board, so it suffices. So I have n. So what I need is, I need a board, I need a configuration. I need a 2 by 2 array which will tell me that whether a queen has been placed here or not, and that will only tell me whether it is placed or not. So I can use a vector of boolean, vector of vectors or boolean. So let's do that, and let's call this board. It will be of size n, and it will, like, I'll initialize it as like false. False means that there's no queen here initially. We don't have any queen on any square of the chessboard. So we will just set that. This would be n and it will be false. So initialize. So what I did is I just initialized my board as false, because each entry denotes whether I have a queen here or not, and initially we don't have queen anywhere. So yeah, what I need to do is I need to just pass this into a function which will tell me the answer, or which would basically increment this count variable. This count variable is the number of valid configurations. Initially this variable is 0 because initially I'm assuming I don't have any valid configuration, and I just pass this as solve n queen. So what do I need to pass? I need to pass index, uh, like uh, uh, the level which I am currently at. Initially I'm at 0th level, and I have to go up till nth level, and I'll also need to pass this board, right? So let's pass this, and this function is not returning me anything. This will just increment the value of count whenever I'm reaching the nth level. So I'm at 0th level, I'll go to first level, then I go to second and n minus 1th level, and then I'll go to nth level. When I go to the nth level, that would be my base case, which means I've seen from 0 to n minus 1, and I've placed queens successfully till there. So I've placed n queens successfully, right? So when I'm at the nth level, I'll just increment the value of counter, and I say, yeah, I've seen one valid configuration. So I just pass this. I'll just call this as void solve n queen, and I'll pass current level. Let's write this as this size, or let's say let's call this board size, and this is just our matrix. This is my board, right? So what is my base case? When I'm reaching the board level is equals to board size. If my current level is equals to the size of the board, when I've seen all n levels, I'll just increment my counter and I'll return. Otherwise, what I do is I iterate over all the columns in my particular level, and I check whether I can place a queen here or not. If I can place, I go to the next level. Otherwise, I just go to the next iteration. So I'll be iterating over 0 till board size, and uh, can I place a queen here? So I'll ask this question by passing this into a function. Let's call that function valid queen position. And what do I need to pass? I need to pass my current x value and current y value. So my current x coordinate, that would be my I, my current y coordinate would be my level, and I need to pass the board, which would tell me that there's no queen which is attacking this particular coordinate, so I can legit place the queen here. So if I can, so this function will return me a boolean variable. It will return me true if I can place a queen here, otherwise it will return me false. So yes, can place here. Now I will just go to the next level. So I will be calling solve in queen. Current level will become +1, board size is fixed, and board is this. And also this board will also change, like this particular index I will place a queen here. So this will become y, this will be current level, and this would be my I, and I'll place a queen here, place a queen, and I go to the next level. If I cannot place a queen here, what I'll do is I'll just go to the next iteration. But it could be the case that like this true got this true got set, so we also have to unset this and place a queen, right? Unplace a queen if already placed. So let's just set this as false. Yeah, so yeah, I need to write this function which is valid queen position, and this is a boolean type. So what I'm passing is my x, and this is my y, and I'm passing this vector. Let's copy this from here, and I'm passing this board thing by reference because it's a 2D array, 2D array, and that will take up a lot of space if I don't pass it by reference. So I need to check whether I can place a queen on this square. So first check would be check for y-th coordinate, like whether I have placed a queen already on the same y-th coordinate. Can that be possible? Like, can it be a case that I have two queens on the same row? In this function I'm setting this as false, so it will never be a case, there'll never be a case when same level will have two queens. So I need not check for this. Can we have a queen which is already on the same x-th coordinate? Well, maybe. So let's have a check for that. So I'll create two variables which will represent my current position, because I'll be iterating backwards, so I need these two variables. So I'll have yy as y initially, and I'll be iterating while my y thing that is greater or equal to 0. It'll be yy actually, and if I have already placed a queen here, this will be yy, let's say minus minus xx. If this is true, if I placed a queen here, we are in trouble. I'll say I cannot place a queen here because there's already a y, there's already a x coordinate which has a queen placed somewhere already in our board for return false. Okay, now I need to reset my y as y and x. Well, x was never changed in the previous loop, so we need not reset it. Now check for left diagonal. Do I have a queen attacking me from the left diagonal? Let's have a check for that. So I'll go up till my x is greater equal to 0 as well as my y is greater equal to 0, and if both this should be y and minus minus and x minus minus. If I have a, if I have a queen placed here, I'll just return false. Right, now check for right diagonal. While xx that is less than the board size. Yeah, so let's have another variable, board size, that would be equal to board dot size. Like as it is a square board, so we can use any board size, or which will give me the number of rows, or I can also use number of columns because it's a square, so both of them will be equal. So I can use this board size and y that is greater equal to 0. Yeah, if board x y minus minus and x would be plus plus. If this is equals to or to, I have a queen already there, return false. If I've passed all these sanity checks, I can place a queen here. Right, I've passed all the sanity checks, I can place a queen here, so I'll just return to, yeah, I place a queen here. When I return to, it will it will go inside this parentheses. It will place a queen here, and it will solve for the next iteration, and this will go on till we hit a base case, which is this. This will increase our count, and then it will just unplace the queen from there, and we'll go to the previous okay, and we'll see whether we can have multiple queen placements at the same level. If we cannot, we will go to the previous level and back. So this seems to be working fine. Like logically this seems correct. Let's just return count and see whether this works. Okay, so this is BOAR, we should be D. Yeah, bore size. Yeah, okay, LVL. This should be current level, right? Current level. This should be small. Yeah, high position board. See. Okay, so we have encountered a runtime error. So where can we have a runtime error? Where we are accessing the 2D array. So it could be here or in the previous loop. So let's say we have created a board of dimensions n cross n, initialized all the values in it as false. Okay, we will pass this here. This is 0, this is n. When my current level becomes equal to board size, I just increase the count. I'm not accessing any value, so should work fine, which is return. and I'm iterating till it is less than board size. I go to valid queen position. Here we are accessing board many times, so maybe there's something issue here. We come here. My curl level will always be less than board size, so it'll always be less than n. So that should not overflow. That should not cause a segmentation fault. Sorry, my I is also less than n. Should be working fine. Current level always less than n. Yeah. So I just maybe there's something here. So let's see this function. Okay, I have not changed the, I've not set the values of xx and yy. So yeah, okay, this should be yy is equals to y. Now let's see. Okay, this works. So let's see this for base cases. Can my n be 0? Given an integer, it can be 0, right? So it could be negative also because it's an integer. Like what should be the answer if it is negative? Like, doesn't make any sense, but let's just try. Why not? Maybe that should not be as accepted range. Yeah, cannot create. Yeah. So if my n is like negative, I just return. What do I return? I return -1 or 0. Just, I don't know. It's not written in the question. Integer n return. It's not written. Well, this is like never going to be this case, but still, for us to not have a crash, we are writing this and we're checking. I just okay. Like, I think this can never be negative, and they should like explicitly write this that we did not handle cases where n is negative, because that's not in the domain of n. So yeah, let's just run this for, let's say, 5. Yeah, works fine. Great. So let's submit this. Last night I just run that, and yeah, this seems to be working fine. So let's have a look at its time complexity and space complexity. For space, we're just creating this new array of size n cross n. So my space complexity is n square, and we're to optimize it, we're using boolean, not integer. So it takes lesser size. And what is the time complexity? So we're going through all the levels, and also for each level. Okay, so we are at level 0. We iterate over all the possible values, all the possible columns. For each column, we make a call. Like, if we can place a queen, then we make a call. Otherwise, we just iterate. Okay, like what would be the time complexity? So let's learn from here. I'm here. Then I make a call to the next level. I make a call here. Okay, I cannot place, so I make a call here and make a call here. Okay. I mean, I'm basically running through all the possible configurations here. For this queue, I'll be checking for all values of q here, and also for this queue I'll be checking for all values of q here, and so on. Yeah, so for like n positions here, n positions here, n positions here, up till n positions, and total, like this is a very massive time complexity. This is n raised to power n. Yeah, so this is exponential time because we are going through all the possible configurations. So time complexity is O n power n. Space complexity, that is O, this is O of n square because of the auxiliary array. So that's it from the video. If you like the video and if you want to see more such videos, please consider to subscribe my channel. That would give me a lot of extra motivation to make such awesome videos for you guys. And if you have any doubts regarding the code, time complexity, the explanation, or any criticism, please free to comment down in the comment section. And I'll see you in the next one.